Hello. Hi guys, ki hal chal? I hope you guys are doing good. In this, we're going to see problem maximum score of removing substring. Spoiler alert in 3, 2, 1. We will see starting off with why we cannot apply DP here because that was the first thing which I thought myself. Then we will see that why we have to apply greedy, how we have to apply greedy via stack. Then ultimately the most improvised approach out of all the approaches, which is via two pointers. Cool, let's start off. But if in the mean, in the mid, or maybe in the end portion, or maybe in the beginning, if you like the video, then please smash like button or comment anything which you learned from the video. Cool, let's start off. It simply says that you are given a string s. As you can see, you are given a string s, and also you are given two integers x and y. Now we can apply two operations any number of times. The type 1 operation is take a substring ab, and then you can remove that from s and gain x points. So I remove that substring ab, and then the new substring, the new string will now become cxbae, and then I have gained x points. Operation 2 is I can remove a substring ba, then I can gain y points, and then as you can see, if I remove ba, I will see abxe will be actually my new string, and then I have gained y points. I have to tell what is the maximum number of points I can gain. Now, when I first saw the problem, it was very evident. Okay, for every, I will go on to all the indexes. Let's say I am at this index. Okay, obviously I cannot remove any pair of size 2. So I can start removing any pair of size 2 if I am at this index onwards. Now, at this point, if my x is 4 and my y is 5, I never know what can come in future. So at this index, I will have three options. Either I can remove a BA, AV, I can remove a BA, or I don't want to remove anything, I can just simply skip. Maybe in future, I will remove some pair. For sure, at a specific character ending with B, there is no possibility of removing a BA because obviously, again, you are not moving forward, you are looking only backwards. So you should end at A just to look for removing BA itself. Thus, okay, this either I can maybe remove AB, or at that point I can remove a BA. Again, other option is I don't do anything and I move on forward. Let's say here in this case, I would have planned to remove AB. Again, I can only remove AB. I cannot remove BA because I have not moved. I cannot look future. I can never look in future. So let's say I would have planned to remove AB. Then okay, I will add that cost and I will move on. And when I say I will move on, I will have to move on to a +2 index. What if I don't? Okay, I just skipped it, which means I'll move on to the next index. If that is the case, then I have option. I can remove a BA now because BA has a higher cost, so I will incur 5. And then next time, okay, I move to D. Here, I cannot even apply AB or BA because again, to apply a BA, you should end at A and the previous index should be B. To apply a AB, you should end at index B, and your previous index should be A. Then this was my strategy. So I thought, okay, I can use a DP kind of strategy where I will take, not take. In my take, I can either take a AB or a BA depending upon the end index. But soon when I looked at through this example, I realized it is not as simple as moving just forward. Your string changes as you remove something or take something. For example, in this strategy, again, let's forget for now that what I am taking, either a AB or a BA. But even if I take anything, even if I take BA, when this portion is gone, I again was able to get another BA. Now, the first question is, what is that data structure in which you move on from a specific index? You take some elements, like, okay, you again, just imagine you're moving on to all these indexes. You found a pair, you remove that pair, and from the top, which was earlier not taken, to the current incoming element, you can again make a pair and you can again remove them. So maybe in future you can again make a pair. What is that data structure? That's simply your stack. So one thing we realized that if I just put it right back, it was a CBBAA. CBBAA. So if I just simply take a use of a stack, okay, I can put C, I can put D, I can put B, I can put C again, and then I can put B again, and then B again. Then I received a A. I will check the top of my stack. Is it a B? Yes, which means I can remove this pair. Okay, I can remove this pair. Okay, this is gone. Now I am at A. I'll check again. When I simply remove a pair B A, I should increase my answer by Y. I should increase my answer by Y. And then you received A. The top of the stack is B. Again, you can remove this pair. Then you received a A. The top is not a B, so you cannot remove a BA pair. So simply push. Okay. Then again A, push. Then B. Oh, you can now form a BA pair. Okay. Simply remove that. Again A, push. B. Now you can form a AB pair. Simply like again, don't push it. Like firstly check, and then if it is not, then push it. Here in this case, you will simply remove it. This is how we know we got to realize that why we cannot use DP and why we will have to use DP, because after removing, things can come close and can form new possible options for us. Okay, that was good. But Aryan, one thing, like I saw one very basic thing. If you had a AB kind of a strategy while you are using your stack itself, what you will do? Are you saying that you will push A, then you found a B, so you will remove it, but then again you found a you will push it, then again you found a B, so you will remove it? So technically you made AB pair, which means let's say AB has a cost of X and the AB has a cost of X, so you got a cost of 2X. Okay, let's take these numbers only. My AB cost was 4, AB cost was 4, so I received a cost of 8. But I can very easily see, what if I would have taken BA first, and then this BA would have given me cost of Y. When this BA is gone, obviously I was able to achieve a AB again. So cost of 5 for BA, cost of AB, which is X itself, is 9. I got a maximum cost. And that's what I wanted. So, okay, you use tag, that's good thing, but we realized one thing, that somehow this X and Y, whichever is higher, I will have to give them as a priority. But then, Aryan, are you sure that, like, you are telling us that you will always try to remove BA first, because BA, which means Y, has a higher cost. So I will always try to see, okay, BA is here. Then when this is gone, another BA is here. Then this BA is here. So technically it feels like that I will remove BA first. When all the BAs are done, then the string will look like CDB CAB. Then I will remove my AB. And if I look at this example itself, then 5 plus 5 plus 5 is 15 plus 4, it is 19. So it's also 19. Yeah, it feels like that I'm greedily removing maximum, like maximum number, maximum, having the maximum score one first, and then removing the lesser score one. But what's the proof for it? Like, is it actually sure or not? Obviously, let's see. Again, whenever you have to prove something correct or not, either you try proving it correct or you go by contradiction. Let's see. We are saying that BA, if I have a BA, I know one thing for sure, that the score of Y is more than the score of X, which means the contribution of BA is more than the contribution of one AB. One BA having more contribution than one AB. In that case, in what scenario my actual AB could have had more contribution? Obviously, when my BA, it could have impacted my AB to not make two pairs. What I mean by that is that if I had A, B, A, B, now I am saying I will put BA first. If I put a BA first, I was earlier, if I would have not put it, I was able to make two AB pairs. So I'm basically destroying two AB pairs, and from that I'm making one AB pair. So obviously it feels like that two AB pairs, which means 2 into X, will be, it can be more than by my, again, it can be more than by Y. As you can see also, 8 is more than my 5. So it feels like that one BA pair is kind of destroying two AB pairs. So in that scenario, oh, it feels like that it might be good. It might be good when you, let's say your Y is, let's say 5 only, but your 2 into X is 4. So it might be good. But okay, maybe in the scenario when Y is, let's say 10 and your X is only 4, then okay, it might not be good. You might again go and take BA only. So is it dependent upon how much Y is more than X? Is it dependent upon that? Technically not, because if we go and look for it, You made this example just to contradict your behavior. But then if you will take a BA first, you will achieve a cost of Y. But then, although you destroyed two AB pairs, which could have resulted in a cost of 2x, but this BA, when it has gone, it resulted in another AB pair, which has again given a cost of x. And as we know that y is more than x, thus y plus x is more than x plus x, which ultimately says that removing your higher cost person is always beneficial than removing your lower cost person first. Ultimately, we realize that now we will remove the higher cost person. Firstly, we'll check who is more, x or y. Again, remember, y is BA, x is AB. I'll first take who is more, and whosoever is more, I will remove them first. How I will remove them? I will remove via stack. Let's quickly do a quick try run and let's see how we will do it. Although we had done it earlier also, but let's do it quickly. So firstly, I have to take a cost. Let's take as total points, because these are named as points y and point x. So I will put C again. I will put out from a stack when I will make a pair. I will put D. I will put a B. I will put a C. I will put a B. I will put a B. I received a. I check the top of my stack. Oh, top of the stack is B. Remove it. Okay, this is done. Again, when I say removed it, I achieved one pair. I should increase my answer by 5. I'll increase my answer by Y was, remember, Y was your 5. X was your 4. So I will simply take this example. Okay, I increase my answer by 5. Again, I received the A. Oh, top is B. Remove it. Remove it. Increase the answer by 5. Okay, A. Put it, because I cannot form a BA pair. Again, A. Put it. I cannot form a BA pair. B. Oh, I can form a B. I can form a BA pair. But should I remove it now? No. Because right now I'm only removing my BA pair. I cannot remove a AB pair. I cannot remove a AB pair right now, because this is the first iteration in which only BA pair should be removed. Okay, so I have to move on. As I move on, I will get A. Sorry, firstly put that B in the stack. Yeah, then I got a A. Oh, I was able to form a BA pair. Okay, remove that. And when I say remove that, I will put a 5 in my answer and then put your B back. Oh, so this is now after removing all the BA pairs, because my Y was higher. This is my now new string. If you have this stack which is representing your new string, okay, simply convert this to a new string. How you will do it? Simply put everything out from the stack into a string. You will get a B, A, A, C, B, D, C, when this is your new string. But again, you see, when we get things out from the stack, it is actually reversed. So this is actually reversed. So reverse it back. So C, D, B, C, A, B. So this is now your new string after removal of your BA. So far the score is 15. Again, now your task is to remove all the possible ABs. Again, use the same stack approach. Push C, okay, C is done. Push D, okay. Push B, okay. Push C, okay. Push A, okay. Push A, okay. Push O. As we push on B, we realized I can form a BA pair. B, B and A pair. Okay, remove it. Okay, and this B is done. Increase the answer by X, which is 4. Ultimately, this is the final state of my S string S, and thus I can say the maximum total points was for me achievable was 19, and that's my answer. Cool. This is the code also. Again, as you can see, I am reusing this capability. One time I am using my stack for this string for y, one time for my string of x. So I will make this modular function that I can call this function again and again for firstly for my string x and other time for my string y. I will call firstly for whosoever has a higher score. So make sure that point. So what I will do, I will make a string s1, I will make a string s2. S1 is for a score of x, S2 is a score for a y. I will make sure again, I will make sure that firstly what I have to call is, firstly I have to call the one having a higher score. So I'll check if my score of x is less than y, which means I need to swap my s1 and s2. I need to swap my s1 and s2. It's just simply saying call for a string having a higher score first. So here the s1, it can be either a BA or AB with the corresponding score as x and y. But I will call for s1. S1 will always be the one having a higher score. So I will firstly call for string s1, which is obviously having a higher score. And then I will call for a string s2, which will have a lesser score. And again, this is points for the string. Points, again, this is the input string, as you can see. This is my string s1. sorry, this is my string S1 having a higher score, and this is a S2 having a lesser score. Now you will see that this string S I have passed in, as address. Why is that the case? Because you realized one thing: after doing the first operation, the new string got, like, it became something else. It became something else. So to get rid of it, one thing you can do is you can call this function and return a pair of integer and a string. Integer gives a score and string will give you a new resultant string. So rather than modifying the input string, you could have resulted in a new string also, because that would have not changed your space complexity. Why? Because you are already using a space because of stack. So okay, no, like, don't worry about any extra space. So what you will do, okay, you will simply start off by putting all the characters into your stack. If the stack size is 0, which means you cannot even check, because see, right now this string is maksad string, which is, let's say, ba. In your case, the point for that string is 5. In that case, this was your input string S. You will simply check that currently at the top of the stack, if I can make a AB pair, AB, which means the top of the stack should be B. Current character which I am trying to iterate on S is A, and the top of the stack is B, which means I have formed a BA pair, which is the maqsad string for me. So in that scenario, what I will do is I will simply pop it out. But if the stack size is itself empty, which means the stack is itself empty, I cannot even look for any top character. So in that case, simply push the character into the stack. But if not, then you will firstly check the current character, which is this S of I. If it is equal to maqsad string 1, which means my current character which I am iterating on is actually equal to A, and the top of the stack is equal to my maqsad string of index 0, which is B. In that scenario, pop out from the top of the stack, pop it out, and then increase your total point by point of 5. But if it is not forming any pair, then simply push it to your stack back. Now, as you will see, it will simply go on and keep on increasing your points. Ultimately, your stack is storing the new string. So again, as you can see, I took this existing string only, but you can make a new string also. It's totally up to you. So ultimately what happened is you remove from the stack, remove, put it in your string back. You know the string is reversed, so you will reverse it back to make it a final new string, as it is passed by address. So string S is being changed on your address only. Ultimately you will return your total points. With that, what you will see, the time complexity for this, as you can see, it is O of n. Again, for one iteration, I'm simply using my entire stack and then I'm reversing it, and then I'm basically popping off from the stack and then reversing it. So for one of this, the time used is O of 3n, and space used is actually, as you can see, one time the space used is of stack. And technically we should not modify the input array, so I will also incur that space, which means my space used will be 2n. And this is for one. For both of them, multiply that by 2. So this is your total time and space used. Now, the task is, again, so far it will work completely. This code will completely work. Your task is, can you improvise it? Can you improvise it? Now, when I say improvisation, let's say I asked you to improvise on both time and space. For that scenario, especially space, if I'm referring, which means that this is your input string, you have to somehow do in place operation kind of. You cannot use stack now because you have to improvise the space. So what you will do, you will try to replicate the behavior what was happening by modifying this string itself in place. But Aryan, still it will incur a space. Yeah, because you're modifying the input string, which is not a good operation, which is not a good strategy, or which is not a good application to do. So you should still take O of n space in consideration, but maybe because of using two pointers and maybe because of not reversing the string again, all that headache you had, let's use two pointers and replicate the same behavior. How I will do it? Let's see. So now again, maqsad. Let's remember the maqsad. Maqsad is that after the first iteration, the string should look like this. Sorry, like this. So what I should do, that the string should look like CDBC, and then BBA is gone, which means this portion is entirely gone, and then A A and then B. This should be my string after the first iteration, which means that for a specific string having a score of y, here the string in our case was a AB, which is the maksat string. I have to simply remove, sorry, that was a BA. I have to simply remove this string and incur a cost of, and basically add a cost of y, and ultimately get this string back. Get this string back. Okay. So I will do, okay, I will simply start iterating. Okay, I'll simply start reading, because what's happening? Ultimately, what's happening is you are checking for a character. Let's say you check for a character A. Then you check for the previous character, which is B. So ultimately, this is what's happening. So maybe somehow I can replicate this by using two pointers, because it's just one pointer where I will keep on moving forward, and one pointer will actually see that do I have to maintain this string or not. Okay, let's see. So I will take two pointers, which means I will have a read pointer which will keep on reading, and then one pointer is write pointer, which will actually make sure that I achieve the string in the end. Okay, so ultimately nothing fancy. C is something I cannot even look for backwards. So okay, I will simply move ahead, and then I am here. Okay, again a D I can look for backwards, but D I will compare with A. It is not matching, so I will again move on forward. Now as you can see, this is R. As you can see, I am moving on forward, which means I am parallelly right pointer makes sure that I'm parallelly building my string, which is the final string also, and this is original string. Now okay, again move your pointer, read pointer and write pointer. Again it cannot make any possible string scenario. Move your pointer, this is your right pointer, this is your read pointer. Again it cannot make any possible scenario. Move your pointer, right pointer, read pointer. Again it cannot make. Just move your pointer, this is the right pointer, this is the read pointer. And now comes the strategy. So what you will do, okay, it feels like that, okay Aryan, my W, which means okay I am here, and after, again technically in code what will happen is after writing it, because as you land on to specific read index, you make sure you firstly write and then increase your pointer. So this is how the code will look like in code. But again, I will show you that this is how. What happened? Firstly, as you come on to any read index, which is this index 5, you write onto that index, and then you move on forward. Then you moved on forward your right index for the future writing part. Which means in future, R will come here. It will write on index 6 the value of A, and then will move ahead the right pointer. Okay, but so far let's say my R was here and my right was here. Technically, okay, my right is here, so I should go and check these two technically. But here let's say I moved my right pointer and I moved my read pointer. So I have written up till so far my string so far is written. Let's erase this. So up till so far my string is written with this BBA. And how it is writing, I will simply say S of right pointer, just to simply do a read pointer, which means whatsoever my read is pointing, simply write it to my W pointer, and then make sure for the next iteration increase my right pointer. You will say, Aryan, why not read pointer increase? Yeah, read pointer will also be increased, but that will increase by other loop. You can also increase here. You can also put a while loop, while like let's say 1 or maybe like R plus plus like this, or you can also have a for loop for it. So in the code, I have used a for loop that while my read pointer is from 0, read is less than n, and then read plus plus. So I'm basically firstly writing, and then because the right pointer has increased and has gone forward, so now this is the state. If this is a state, you have to check, do you form a BA pair, maksat string, are you able to form that or not? If yes, as you can see, you are able to form it because A is here, B is here, you are able to easily form a maksat string, which means W minus 1 and W minus 2, they are matching with maksat string of 0, maksat string of 0 and maksat string of 1. In that scenario, you have formed a pair. So increase your total points by the points of y. Increase it, which means points will actually become now increased with 5. Now, what should happen is that technically these two are gone. So again, imagine that this is I am erasing right now. Okay, so imagine these two are gone. when these two are gone, read pointer will still keep on reading forward because I have read this entire scenario. But as these two are gone, so the next thing which I should start writing should be back from here. So you see, I moved two backwards because I know these two are gone. So now the new location of writing should be this and not this. So I will move two backwards. Now my new right location will be 5 index 5. Okay, now move on forward. I move on and write on this specific index. I will write again, let's erase this. I will write a. And as you know, as I write simply, I move on my index W. Now I will again compare W minus 1 and W minus 2. They are matching with my maksad string. So again, increase your answer by 5, move your W pointer by minus 2. So W will actually again come back here. Again, so you see, I am kind of overriding my actual string. Again, as you move on forward, your read pointer, you will simply write. So this will be overridden with a of this value and simply move on forward. Next time you move on forward, you put in a. Okay, you put in a, then you move on forward. Here it is W. Then again you put on R. Then then you will put on this B here. As you see, this B is being put here at the right pointer. So I'm basically writing, building my string in the prefix portion of the S. Okay, then after this is written, my W pointer should for sure move. As I move here, I will have my read pointer. Firstly, my prime task is writing it, so I will write it, and then after writing, I will move my W pointer. I realized I have formed a BA pair. That scenario, increase the answer by 5 and then move your pointer back to W. Again, move your read pointer, and as I move my read pointer, I will put it as B. And then ultimately I will again, when I write something, I should make sure I should increase my pointer. The next time when I'm about to read, I have reached the end. So this is the final string. What is the final string? Final string is starting from the index 0 up till the length of what is this length? This length is 7. See, my W is pointing to an index which is afterwards, which is 7, but the length also here is 7 because the indexes are 0 based. So I can say the final string, again, I have received my points, I have received my points, and I can also say my string has now become a substring from 0 to up till index of W. This is my new substring, and then return the substring, basically modify the string in place, and then again apply the same operation for your maksad string as AB with the cost of X. Ultimately get the answer. Cool. Let's see the code again. This was the entire dry run. Firstly, this will remain as it is, exactly same. It's just that now in this scenario, what I will do, I will have my read index. Then firstly, I will write and also increase my right pointer by +1. In that scenario, if I know that I have at least one previous index, when my right index is more than 1, which means I have at least one previous index, and then I am matching with my maksad string, then I should firstly move my right pointer back to -2 and also increase my total points by that specific point which are coming to us. Repeat this process simply. It is just two pointers which are moving, in which R is always moving and right is only moving -2 back, -2 back. So it will take only O of n time. And then ultimately here you will grab the substring from 0 to right index. This is substring which you will grab, and ultimately again this is being modified in place only, and then ultimately returning your total points. Now the space used, as you can see, the time used for one of this operation, let's say if I ask for time will be O of n for this operation and O of n for a substring operation. So total time is O of 2n. Space used, although you can see that there is no stack used, but still, because of you are modifying the string S in place, so you are modifying the input array S, which is not at all a good practice. So you will have to take a space of O of n also in consideration. So in total the space will be multiplied by 2, which is both time and space, because of another same function. 4n, 2n. Earlier it was 6n, 4n. So you reduced your time and space by 2n, 2n. That's a good thing. That is your most optimum approach. Cool. I hope you guys got it. If yes, then do smash like baby. Cool. See you. Goodbye. Take care. I don't know. Okay. Bye bye.